Hey, good morning, you guys. So today we're working still on developing and making a line plot. So I'm going to dig right in with this. Let's just do our three read as we start. Kira bought 12 different types of stickers to decorate her scrapbook. She measured the width in inches of each type of sticker and wrote down the results. Make a line plot to organize and display the data. So here's the data. And I can look right here and I can see we have a quarter, 3/4, 3/8. So the the smallest number appears to be that we're going to have for denominators going to be eighths. So here's quarters, quarters, eighths, quarters, quarters, eighths, halves, and I know I can decompose halves into eighths. So this becomes really easy. So I'm going to move my Screencastify sharing option down here so you can see it. So I put my scale in on the line, and you can do the same. So here is 0, here is 1 whole right there. And then all I did is I started out with the half right here. So here's 2/4, which is a half, which is 4/8. Then I cut my halves in half into quarters. So here's 1/4, here's 3/4. So 1/4 is the same as 2/8. 3/4 is the same as 6/8. Okay, and then I filled in my eighths between my quarters, decomposing those 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8, which is the same as 1 whole, 0/8, same as 0. Okay, so now all we've got to do is put these in. So I don't get confused, I'll start with the top line, 1/4, 3/4, 3/8. 1/4, put 1x in for 1/4. 3/4, put 1x in for 3/4. And then 3/8, put 1x in for 3/8. So this row is done. Okay, 3/4. Okay, put another x in. 1/4, put another x in. 5/8, put an x in. Okay, that row is done. Now we have 1/8, 1/2, 1/2. So here's 1/8, here's 1/2, and another 1/2. So every time we get some data, it goes in as an x. And then we have 1/2, 1, and 1. So here is 1/2, here is 1 whole, and 1 whole. And now we've got the data in. So we had to make a line plot to organize and display her data. So there's 12 stickers. Let's see if we have 12 X's. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we've got that done correctly so far. All right, turn the page. This is always just kind of a review of what we just did. So if you didn't get it a little bit, you have a chance to kind of take it in. So explore the different ways to understand making a line plot. So Kira bought 12 different types of stickers to decorate her scrapbook. She measured the width in inches of each type of sticker and wrote down the results. Here's her results. Make a line plot to organize and display Kira's data. Well, and we just did that on the page before. So model it. List what you know and plan how to make the plot. The fractions are in eighths, fourths, and halves. So that's why we turn them into eighths. The narrowest sticker is 1/8. The widest sticker is 1 inch. The line plot will start at 0 and go up to 1 inch. And that's because the narrowest sticker is 1/8, which is just larger than 0, and the largest is 1 inch. The line plot will show an X for each of the 12 stickers. That's totally true. And the line plot will have a title and a scale label. Okay. And that's probably one thing that we didn't put in when we were doing it. We could have totally put in a scale label at the bottom. So we're going to do that now. So think about what we could be putting in for our scale label. All right. Okay, so we've got right here for Kira's, we should have width at the bottom. Okay, so down here, when we put it in, it should say width. Okay, and up in the top, and it's kind of crazy because it's the same exact thing as the bottom, really. It's sticker width. Okay, now they want us to regraph everything. Okay, so let me see if I can make this a little bit smaller. So we're going to put them in again. So it looks like, and now that we have this, I realize that these are in eighths. So I'm just going to number them down here. 1/8, 2/8, which is the same as 1/4, 3/8, 4/8, which is a half, 5/8, 6/8, which is 3/4, 7/8. Okay, so they started with 1/4, and then they have 3/8, and then they have 3/4. Okay, so they've got this first one done like we did last time. Okay, and we just put them in again. So we go to 3/4, which is 6/8 right here. Okay, then we go to 1/4, which is 2/8 right here. Then we go to 5/8, put it in. So for every piece of data, we always put an X. Okay, 1/8, 1/2, 1/2. So here's 1/8, here's 1/2, here's 1/2. And I'm going to make that X a little better over here. Okay, then we have 1/2, 1, and 1. 1/2, 1, and 1. Okay, count up our X's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. 12 pieces of data. So you had your title, okay, and you had your scale title. All right, let's continue on. Look at the first modelet. I'm going to tear this off really quick. Okay, why is it a good plan to go from 0 to 1 inch for the first line plot? So why did we go from 0 to 1 inch? Well, that's a pretty simple answer. The only reason we did it that way is because that's where that's the range of our data. Okay, our data goes from 0 to 1 inch. All the stickers are that wide. All stickers are between 0 to 1 inch in width. So what scale is used for the line plot in the second modelet? So in the second modelet, we just worked on, and we did it better when we did it, but we went by eighths right here. So we're going to say 1/8 inch. Why does this scale make sense for the data? Okay, well, it makes sense because all data can be entered as eighths if you find equivalent fractions. So remember, pause as we go if you're needing to. Okay. Now, next thing. Oh, there goes our lights. That's a pretty good one this time. It's been pretty sensitive this morning. It goes off and doesn't want to come back. So hopefully you guys are hanging in there. The tick marks in the second modelet are not labeled with fractions. Do they have to be? So you don't have to label all the tick marks. You can count eighths for your data points, okay? But it's for me, it's easier to label them if we go. So like, for example, 1/4 is equivalent to 2/8. So, you can plot an X on the second tick mark after 0 if you want. And I'm not going to write this all down. I'm just going to kind of explain this one. I'm just going to put little 3 ellipses on this. No, you never have to just write them down. As long as you can count you know, looking at these tick marks, if they weren't there, all you have to do is count how many spots you had. Remember, so when we are looking at this, if we know here's 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 line segments here, and now you could just go and count each one of them. So you don't have to label the numbers, but it does make it easier. So you could say, well, there's 1/8 or 1/2/8, 1, 2, 3/8, and so on. So that's what you could have done. So it says complete the line plot in the second model it. We did that, and we put a title in it. So how do you use a line plot to organize measurement data? This is really simple. You put an X on the scale for each data point. Okay, so, and you make sure you get all of them. All right, let's move on. Okay. Sean records the lengths in inches of several bugs he collects for a science project. Complete the line plot of the data. Now, for me, I already went and I put these into eighths already because I looked at the denominators and I can see that we have 8 and we have 4. And we don't have any halves, but we do have some wholes. So let's take a look at how many line plot pieces, how many pieces of data we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of them. So we have 10 pieces of data when we're all said and done. Okay, so let's start with just labeling what our title should be. So he records the lengths in inches of several bugs. So let's just call this lengths. So we have bug lengths. Okay, and then at the bottom, it's a pretty simple title, length in inches. Okay, so first one is 1 and 5/8. So here's one hole, and now we can just do what we were talking about. So here's 1 and 1/8, 2/8, 3/8, 4/8, 5/8. Here's 1 and 5/8. Okay, and I can write it if I want. Here's 1 and 5/8. Okay, and 4/8 is right here. That's a half. 3 1/4. Okay, so here's 3. So here's 3 and 1/8, 3 and 2/8, which is the same as 3 1/4. 1 and 3/4, which is the same as 1 and 6/8. So here's 1 and 5/8. Here's 1 and 6/8. 2 and 7/8. So 2 and 7/8 is going to be right before 3 and 8. So we're going to put an X right there. 1 and 3/4, which is 1 and 6/8 again. Okay, 3 1/4. So here's 3. Here 3 and 1/8, 3 and 2/8, which is 3 1/4. Now we have 1 and 5/8 again. We have 2 and 3/8, 2 and 1/8, 2 and 2/8, 2 and 3/8. Then we go to one whole, and then 1 and 3/4. So here's 1 and 5/8, 1 and 6/8, which is the same as 1 and 3/4 because I can double. My 3 times 2 is 6, 4 times 2 is 8, 1 and 6/8 is the same as 1 and 3/4. Okay, so now let's count our pieces of data. Hopefully we got 10 in there. Sometimes I've missed a few. So let's take a look. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Our pieces of data are there. All right. Next one. Dolores trains for a 5-mile race. She keeps track of the distances she runs each day in miles. in a training log. Use the data to make a line plot. Show your work. Well, so this is a chance for you guys to go through, make your line plot right now. Let's find our lowest number, whole number, and our highest whole number. And if it's fractional, we might have to go to the whole number nearest it. So right now I'm seeing 4, I'm seeing 7. So we're going to have to go between 4, and we can't just go to 7. We're going to have to go to the next highest whole number, which is 8, because we have a fraction of this. So I'm going to start here. This is going to be 4. Okay. This is going to be 8. What's going to go halfway in between? Hoping you're saying 6. Okay. Now what's halfway in between there? You know it. 7. Halfway in between here, 5. Now, let's look and see what we have to turn this into. We have quarters and we have halves. So we can just quarter all of these into fractions, all these line segments into quarters. So start by cutting them in half. And let's use a hash mark that's longer for the halves. That way we can see our halves. Okay. And then our quarters will use a short little hash mark. So all right, so let's start with week 1. First one, 7 1/4. Here's 7, here's 7 1/4. Day 2 for Tuesday, 5. Wednesday, 6 1/2. Thursday, 5 1/2. Friday, 5. Saturday, 7. Sunday, they ran 6. Well, at least they do work. They're training for a race. They're running every day. That's a good thing. Next one, week 2, 4 1/4, right here. Then we go 6 1/2, 5 1/2, 5, 7 1/4, right here, 6 1/4, right here, and then we have 4 3/4. Person got lazy this Sunday, but that's all right. Okay, so let's take a look. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, or 7 times 2. But there's 14 X's. Let's see if we have 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Which distance did they run the most? Right here, 5 miles, right? Which distance did they run the least? Which would be all these single outliers that just have 1 X. Okay? Turning the page. I'm going to move before the lights turn off. I just have a feeling right now. All right. Rosa's grandfather gives her a box of old foreign coins. She measures the diameter of each coin, diameter's distance across the circle. Then she makes a list that shows the diameters. How can Rosa show the data in a line plot? Begin making the line plot by making a number line from 0 to 1 in eighths. So right down here, they went from 0 to 1 and they divided it into eighths. Make 1 X to stand for each coin in the table. The line plot shows 3 of the 12 values on the list. So right now, let's take a look. So we are 0, 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, and that would be 8/8 or 1 whole. So right now at 3/8, they have 3 of them. So here's 1, here's 2, here's 3. Okay, so we're going to just fill in the rest of this. Remember, that's all you're doing when you are making these is you just fill in the data points. It's pretty simple concept. So we're going to go 3/4. And now if they're in quarters, you're going to have to turn them into eighths. So this would be 6/8. 6/8. So we have 2 6/8. Circle 3/4 twice and do 6/8. 2 of them. 7/8 has 1, 2, 3, 4, 5 of them. And then we have 2 5/8. Now we've got them all in. So there should be 1, 2, 3, 4, 5, 6. So there should be 12. So let's look. 3, 5, 7. 7 and 5 is 12. Okay. Which data values do the 3 X's rows of draws represent? This represented 3/8. So 3 coins, okay, that are 3/8 inches in diameter. So graph the rest of the data. Of course, we already did that. Okay, let's turn the page. We're almost done. Just keep with me. I know you guys are doing well. So Gabe has a collection of stamps. He records the heights of the stamps in inches. 1/2, 1, 1.5, 2.5, 3, 2, 2, 1/2, 1, 1, 2.5, 2, 1.5, 1, 2.5. So, same thing. Complete a line plot of Gabe's data. Label each tick mark for this line plot. Okay, let's start with 1/2, then go to 1. Go to 1.5, then 2.5, then 3, then 2 twice, then 1/2, then 2 ones, then 2.5 once, then 2, then 1.5, then 1, then 2.5. All right. So looking at that, think about the heights for the stamps. The one with the greatest height, he's got 4 that are all 1 inch. Okay. The smallest height would be, where the smallest amount of heights, he has 1 that's 3. Okay. The smallest number for height is 1/2 though. Okay, so if I went from the largest height, which is 3 inches, to the smallest and found the difference, which is 1/2, I'd just go 3 minus 1/2, and we could ask a question that way and say, well, the difference in this stamp and this stamp in height is 2.5 inches. Okay, Gabe also records the widths of some of the stamps in inches. Okay, make a line plot of Gabe's data. Okay, so we're going back down here, okay, with the widths. So we've turned this into quarters already. And as you can see, and I'll just kind of make those a little bit longer line for our halves so we can easily find them. Okay, so let's start with 3/4 right here, 1 whole right here, 1.5, 1.25, 1.5, 1 whole, 1 3/4, 1 3/4, 1.5, and 1/2. Okay, so count up our numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Count our X's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We've got them done. What scale did we use to make our plot? What did I turn this into? We have, for our denominator, we have quarters, we have halves, so we easily turned it into our scale was in 1/4 inch increments. Okay, that is it for today. I'm hoping you guys are doing well. Hang in there. Keep working hard. We'll move right along for tomorrow next time. So I'll see you later. Have a great day. Bye, guys.